B, your chemistry teacher. Today, we are still going to continue with the laboratory. Remember that our last class, we have discussed on how we can calculate percentage impurity from a given substance. Today, we're still going to look at the laboratory and see how we can be able to prepare or rather let us say dilution of standard solutions. Okay, let us say we'll look at dilution of standard solution. Dilution of standard solution. Okay, so today we'll look at dilution of standard solution. Do not forget that you owe me a duty by being part and appreciative of this class by simply sharing this video. Don't forget to share. Please don't forget to share. Share these videos from the YouTube channel to your friends. Share them to your colleagues, to all your groups, and ensure that you tell them to subscribe so they can be able to see these videos as soon as they drop. Now you also have a Facebook page. Don't forget to go there, share, like, most importantly, share. And then you like, follow, and leave your comments as well. We are going to look at the dilution of standard solutions. If you look at previously in the classes that I had with you, we already discussed how we can prepare standard solutions in the lab. Now here, we want to see how we can dilute them. See, we have what we call serial dilution, and sometimes you can prepare certain amount of a particular solution from a standard solution. That is to say, you prepare 0.1 molar standard solution and you want to still re-prepare another solution from that standard solution. Sometimes you are asked to prepare maybe 0.01 solution out of a 0.1 molar. Sometimes you are asked to prepare 200 mils, okay, or 200 cubic centimeter of 0.1 molar standard solution. How do you go about all this? These are very important. If you must study chemistry or chemical engineering, you must understand how to prepare standard solutions and how to also do dilution of standard solutions. Otherwise, you have a huge problem. Now let us take a look at a typical example of how we can dilute standard solution. Let's assume that you were given sulfuric acid. Okay, you have a reagent, and that reagent is sulfuric acid. All right, let's say you have sulfuric acid H2SO4. That is the reagent you want to do what? Do a dilution, and you are asked that you should do what? You should prepare 250 cubic centimeter, okay, of 0.2 molar sulfuric acid. This is just the question. You want to carry out an experiment in a lab. You do not need 0.2 molar sulfuric acid as its concentration. You rather need 250 mils of the 0.2 molar concentration. How do you go about the dilution? How do you go about the dilution? You do not need the 0.2 molar acid. What you need is 250 mils of the 0.2 molar acid. How do you go about the dilution? Now that's what we are going to do right now. Okay, in order for us to do that, we have to first understand that in the preparation of standard solution out of sulfuric acid, specific density is very important. If you don't consider the specific density, you will not be able to get the right result at the end of the day. So we look at the specific density of sulfuric acid. And the specific density of sulfuric acid is 1.84. It is constant. It's what you must know. It's what you must carry in your heart as a chemist. So, now, we must know that specific density specific density of H2SO4 is 1.84 grams per mole. That is the specific density of H2SO4 is 1.84 gram per mole. But if you are preparing a standard solution, it is against 1000 mils. It is against 1 dmq. Alright? So we are going to link the specific gravity to the standard volumetric flux you use in preparing your solution, which is 1 dmq. So it implies that 1 dmq, okay, of H2SO4 preparation by weight is what? 1.84 times 1000. Now this is because the 1000 cubic centimeter is equivalent to 1 dmq. Alright? So if we are linking by weight of sulfuric acid through a 1 dmq, we multiply 1000 by 1.84 and we are going to have 1840. That is what we are going to have. 1480 grams. That is what we're going to have as the weight. By convention, we can say the mass of what? Of the sulfuric acid in 1 dmq. Now, if this is gotten, I want us to also know that we are looking at concentration when we talk about 250 mils of 0.2 molar. We are looking at concentration. And this, of course, is our second concentration. We have to look for the first concentration, which requires us to prepare 250 mils. And by doing so, concentration is given as N over V, where, of course, your N is the amount of acid in solution, and the V is the standard volume. But your N is always given as what? Always given as the mass over the molar mass. This mass, of course, is the one you obtain from the specific gravity against the standard volumetric flux you are using for your preparation. So it means that your N will be 1840 grams over what? The molar mass, which is 94. Of course, the molar mass of sulfuric acid is 94. If you use a calculator to do this division, you'll see that what you have will be 18.87. That's what you have. This is your amount of acid in solution. So you need to now do what? Bring it to this point. We will now have 18.87 all over the volume. Okay, now let me clean this. Okay. So at the end of the day, we'll have now that our concentration, which is N over V, is equal to 18.87 all over the volume. And of course, your volume is 1 dmq. And this will still give you 18.87. Okay, now, with this, we can now go into the understanding of how we can get that particular amount of volume that you can use to calculate or to prepare or dilute 0.2 molar to get 250 mils. But C1V1 is equal to C2V2. You are familiar with this because this is, of course, concentration of the initial concentration, initial volumes, and the final volume and final concentration. In this case, your C1 is, of course, this concentration that you have calculated. So that means you have 18.87 times your volume, which is V1, and that is the volume we are looking for. While C2 is 0.2 molar, which is what you're supposed to dilute. And then your V2, of course, is 0.025. Remember that 0.025 like we had done earlier, is 25 mils, 25 cubic centimeter divided by 1000 cubic centimeter, which of course is supposed to be per 1 dm3. So I have to convert your volume, which is 25 mils, into what? dm3 by dividing. So this value now is in dm3. Okay, now with this, therefore V1 will be equals to this all over this, 0.2 molar times 0.025 all over what? 18.87. So your V1 will be equals to what? When you divide this by this, you have 2.6, you have 2.4, okay, you have 2.4 cubic centimeter. This is what you have. You're going to have initially, you have 0.00249 or 245 something, and that will be rather in dm cube. So you convert it from dm cube to what? To centimeter cube by dividing by 1000. So you're going to have 2.64. That means that 2.64 is the amount of acid, the amount of H2SO4 that you need, that is required by you to prepare 250 cubic centimeter of 0.2 molar sulfuric acid standard solution. You have diluted it. You have diluted the concentration. If you were preparing 0.2 molar of sulfuric acid, you will use like about let's say 16 point something cm3 to prepare 0.2 molar. So you can see that to dilute that particular 0.2, which is 16 point something, okay, per 1000 ml, to dilute it to 250 mils, you will rather need 2.64 cubic centimeter H2SO4 acid to do that dilution. I'm sure that you have been able to learn something again today, how to carry out dilution or standard solutions. You have to know these things because they are very important. You can be confronted with this even at secondary school laboratories, even in your university laboratories, even in your company laboratories, where you need to dilute certain solutions. We are going to look at how we can carry out serial dilution in our next classes, and then see how we can go about other laboratory techniques before we go again into the normal classes, normal courses that we have in our various universities. Do not forget to share, very importantly, share these classes to your groups, to your colleagues, to your friends, and ensure that you remind them to subscribe to be able to get these lectures and join us in this beautiful thing that we are doing. Don't forget also to like, send in your comments. I will answer those questions. Also, do not forget to follow at our Facebook page, Dr. B Chemistry or Science Classes. Don't forget to share also those Facebook videos you are seeing with your colleagues and friends. Don't forget to like and leave a comment. Until next time, it is bye.